So, now we will see equations of uniformly accelerated motion by calculus method. Now, previously we have done by using graphs, or that is a graphical method. So, now in calculus method, first we will come to the velocity time relation. See here, in velocity time relation, you know it, velocity A is equal to dv upon dt. What type of acceleration is this? That is a instantaneous acceleration. So, the instantaneous acceleration at any time at an instant is given by dv upon dt, whereas dv is a small change in velocity and dt is a small time interval. So, we can write dv is equal to a dt. Now, we have to calculate velocity from this. So, we have to integrate. Suppose we take here at t is equal to 0, velocity is equal to u, that is called initial velocity, and at t is equal to t, velocity is equal to v. This is the final velocity. So, now by taking these two limits, time 0 to t and velocity u to v, I will integrate this equation. So, we will be getting dv here u to v is equal to a dt 0 to t. Now, here we can write v minus u, this is the integration, and by putting the upper limit and lower limit, upper limit minus lower limit is equal to a is outside here, here we can write t minus 0. So, now here we can take v minus u is equal to a t, or you can write v is equal to u plus a t. So, this is see here velocity time relation by using calculus method. It is also very simple, but you need to do this method also. Now, we will come back to the another relation, that is called displacement time relation. So, here in displacement time relation, first we will take here velocity, we can take instantaneous velocity, that is dx upon dt. Dx is a small change in position, that is a displacement, and dt is small time interval, or we can write dx is equal to v dt, or we can write dx is equal to u plus at dt. Now, again we have to integrate. At t is equal to 0, we can take displacement or the position is equal to x naught, and at t is equal to t, we can take position equal to x. By taking these two limits 0 to t and x naught to x, we will integrate it. So, we will be getting dx x naught to x is equal to u dt 0 to t plus at dt 0 to t.